So welcome to the 13th ICID webinar for this year. And through the webinar, we are attempting to extend our knowledge dissemination and spread the new technologies and new approaches across the professionals forum in the sector of irrigation and drainage. Today, our title of the webinar is this technology to reduce energy consumption for water spreading and pipe production in hose reel sprinkler irrigation. The issues presently affecting us today is the reduction in the energy consumption and more efficient use of water. So this the irrigation which is in the field where a lot of loss of water takes place because of the defective or the defects that get introduced in the various conveyance mechanisms, especially pipes, where this wastage of water can be avoided by taking these new technologies, which the Professor Ghinassi is going to demonstrate. Dr. Ghinassi is a researcher at the Department of Agriculture, Food and Forestry Systems of University of Florence since 1996, and he is carrying out field research on irrigation management and water productivity. And from 2004 to 11, he was in charge of the research projects on actual agronomical and economical performance of irrigation at farm and scheme level in different areas of central and north Italy. And the expertise of Mr. Ghinassi is on agricultural hydraulics and irrigation, performance evaluation of irrigation systems, strategies, system selection, design and management to optimize resource use, international work experience. He is a teacher at University for BSc and MSc courses on agricultural hydraulics and irrigation, an active member in working groups of ICID, and representative of the Italian National Committee. And he has authored a number of scientific publications and books. So today now we will, and he will be assisted by expert assistant Mr. Sergio Sacchini. And now we can hear from Professor Ghinassi and assistants for his on the work of these water saving techniques. So I will invite Dr. Ghinassi to take up the presentation and webinar.
Yes, thank you, and a good day to everybody attending the webinar. In the presentation, we will illustrate the first results on the use of new technology, allowing energy saving in the practice of traveling sprinkler irrigation. We will present the preliminary results, and we will discuss about the results themselves. And here with me, Dr. Sacchini, that will introduce himself and will support me in the presentation.
Hello, everybody. I'm Sacchini, one of the two owners of the Italian company that developed this project, and we are pretty confident that it will, let's say, be very important for energy saving and for the environment, not only for our brand, but actually for generally for this kind of irrigation system.
Yes, let's move to the presentation, and the presentation is smart technology to reduce energy consumption for water spreading and pipe production in hose reel sprinkler irrigation. And the presentation is made of 5 sections. In the first one, we will describe the hose reel sprinkler irrigation, the main characteristics and advantages and disadvantages. And then description will be on the device that is conceived to reduce energy consumption during field operations. We will illustrate the evaluations carried out at the field level, and we will consider the results that have been collected during 2 seasons. And then we will move to the conclusions. What about hose-reel sprinkler irrigation? It's widely used worldwide, and for example, in Italy, 8,100 hectares are supplied by hose-reel machine for this kind of irrigation. The hose-reel irrigation has several advantages. Probably the most important is the low cost of the irrigation per hectare, and also the flexibility of the system itself. Among the disadvantages of this kind of irrigation is the energy demand during field operations, especially when the irrigation is carried out by big gun, and other energy is requested for other field operations. For example, the movement of the cart along the field during the unrolling and the rewinding phase. Moreover, when the energy, the traction force is very high, some possible damages may occur to system components and especially to the hose. The energy in this kind of irrigation is used to supply pressure to water and to provide the unrolling and unwinding of the traveling components, the cart and the high-density polyethylene hose along the field. And some problems, as anticipated, may arise due to high or when the traction force applied to the pipe is very high. For example, the hose can be damaged in terms of yield strength, and mechanical components of the machine may suffer the excess of traction, and in some cases also the stability of the machine. And generally speaking, the traction force that is applied is affected by the friction between the field surface and the sliding component, in particular the hose. Also, it's important the weight of the moving components, the unrolled pipe and the cart. It is possible, or it would be important to reduce the traction force by reducing the friction during the movement of the hose onto the ground, and this opportunity has been proved to be a key strategy to cope with these issues. So for this purpose, a device was conceived in order to reduce energy consumption during field operation. The device was conceived by the factory Ireland, and it is still at the prototype stage. The name of the device is Protector, and it was awarded as Best Technical Innovation in 2016 during the International Exposition of Agricultural Machines. Moreover, industrialization is supported by an European project, and the system is also patented. In which way the system works? The system is made of a tape that is made of different materials, and the tape is rolled up in a small reel that is positioned in the traveling cart, and the tape has to be connected to irrigation machines. The way Protector works, during the pulling of the cart for the positioning, both the hose and tape unroll from their reels. And the tape is underneath between the polyethylene hose and the ground. And here it can be seen during the field operations. And during irrigation, both the hose and tape roll up in respective reel. And field evaluations were carried out since 2017 and also in 2018. And the field test the tests are still in progress and are carried out in farms located in Padana Plain. The aim of the field test is to evaluate the influence of protector on the traction force applied, and to evaluate the possibility to use thinner pipes given the same outer diameter. And moreover, it's important to assess the impact on the use of energy during the economical lifetime of the machine in order to assess the impact on the environment. Some prototypes were used on in different contexts, on sugar beet at the different levels of development, the same on alfalfa, and the tape was also tested on bare, hard and dry soils. And the tests were carried out in order to assess the influence of the protector. So the test was carried out with and without protector, and with the pipe empty and filled of water. Okay. During the positioning of the cart, the hose is unrolling, and during the field test, measurements were made and readings were made every 10 meters, moving from the starting point. And for measurements, we used hydraulic dynamometer shown in the photo, in the picture, and the dynamometer was positioned between the cart and the tractor, and the applied traction force was measured along the cart lane, and the traction force increases almost linearly. And this is due to the fact that the friction coefficient is more or less the same, and the speed of the traveling cart is constant. And this characteristic, that is the linear increase of the applied traction force, was found in all the test conditions. Let's go to the results. For example, here we are looking the response of the use of protector on sugar beet. The black and orange lines represented the increase of the traction force along the field, where the distance of the unrolled length of the hose is given in meters. And in this case, comparison was made in the same day and on the same crop, in the same field. on the pipe with protector and the pipe empty. The black line represents the evolution of the traction force when the protector was used and the pipe was filled, and the blue line represents the evolution of the traction force when the protector was not used. And in the latter case, we can see that the distance covered by the tractor was limited to up 180 meters, and the traction force applied was very, very high. In the other cases, the traction force was limited, and we can see here the influence of the weight of the pipe in terms of applied force along the field. The hose used in this test was 14.1 kilo per meter when filled, and 4.6 kilogram per meter when empty. This is the case of alfalfa, and the evolution of the traction force is very similar. In this case, we used another hose diameter with a different weight, and in both cases, alfalfa and sugar beet, the constant speed of unrolling was 5 kilometers per hour. As we can see, at the end of the field, that was 500 meters long, the applied traction force on the empty pipe using protector was about 1.5 tons. Yeah, this is another measurement, another test carried out on the same crop, but in another field, using the same pipe, the same pipe type, but a different unrolling speed, using protector, and when the pipe was filled of water, and the other measurement represented by the blue line is about the pipe without protector, but filled of water. And the difference can be appreciated also in this case. Another test was carried out on dry and bare soil, and under these conditions, due to the low friction coefficient that is quite typical of bare and dry soil, differences are minimal or nil between the sliding pipe with protector and without protector. And so at the end of the field test, we can summarize friction coefficient values, and so they have been grouped into two sections. The coefficient values under protector, and the other group is related to hose over different field surfaces. So the first case, when protector is used, the range is from 0.13 to 0.25. And 0.13 is the case during the test on bare and hard soil. And the other cases, the range is wider, and because the friction coefficient depends on different parameters, for example, the soil coverage, the crop type, and the development of the crop itself. Then we can also just a few words about the energy used during the retrieval of the cart, and you can see that the energy during this field operation is energy is in charge of the irrigation machine because it is taken from the irrigation water. But the situation, the conditions under which the retrieval is carried out refers mainly on the speed that is lower than the unrolling speed, and compared to unrolling, the variation is similar and it is linear. This part will be developed in detail in the next future. So these preliminary evaluations allowed to consider the use of different hose types, especially thinner hoses, and this is allowed by the reduction of applied traction force given the same outer diameter. It is possible on condition that two aspects are considered. The first one refers to the pressure that should not exceed the threshold value that is suggested by the hose manufacturer. And in this case, we selected a pipe that was able to work safely at 10 bar. The second condition is that the applied traction force is less than the hose yield strength. So we applied the formulas that are reported here in this slide, and we also calculated the maximal hose length that can be pulled. So we, under these preliminary conditions, applied the new approach to a reference scenario that is typical of North Italy, and refers to irrigation with gun sprinkler positioned in a hose reel machine. We tested, the evaluation is carried out on the hose with outer diameter 140 millimeters, and we compared two different internal diameters. The first one is typical of the thinner pipe. The second one, 124 millimeter, the first one is typical of the normal hose, and the second one, 124 millimeter, is typical of the thinner pipe. So selection of nozzle diameter was made taking into account the outer diameter of the hose, and also the pressure at the sprinkler inlet was related to the nozzle diameter in order to have a specific characteristic of the precipitation. We assumed a seasonal irrigation depth that is 2,100 cubic meter per hectare, 2,100 cubic meter per hectare, and the applied depth per irrigation 300 cubic meter per hectare. So we made our calculations on 7 irrigation per season, taking into account the minimum irrigation interval and the maximum irrigation time per day. And taking into account the hose characteristics, we concluded that the maximal allowed length due to pressure was 820 meters. The maximal allowed length due to traction force was 854 meters. So we selected the first one, of course. We assumed also, in order to assess the impact on energy use, the overall efficiency from the energy content of fuel to the energy that was delivered to water by the pump. So we assumed 50% the value of overall efficiency. Evaluations were really referred to the economical lifetime of the machine that traditionally is put in 15 years. Last condition was to consider the field as flat. So here reported some values. They refer to the energy use, the impact on the climate given in carbon dioxide equivalent, and the energy cost per hectare. Below the table, the information on the specific element in the table. So as you can see here, we refer to the larger diameter at the bottom of the table. And for example, the maximal pressure at the inlet of the hose is 10 bars, 100-meter water column. And the friction losses allowed by the thinner pipe is 37 meters versus 61 meters of the traditional pipe. So the result is a lower consumption of energy, a lower power for the pump, lower consumption of energy in terms of diesel used by the pump, lower emission of carbon dioxide equivalent in kilograms per hectare, and minor cost. It is in this case about 20% less with respect to the traditional hose. And the difference in the cost in the total cost in euros per year is about 1,000 euros. It is about 20%. And the evaluation of energy use and the impact on climate was also assessed, taking into account in this slide of the impact and the cost of the hose in high density polyethylene at the end of the economical lifetime of the machine. We assume that the economical lifetime of the pipe is coincident with the economical lifetime of the machine. And the impact is given in carbon dioxide equivalent, and the reference period is the production phase. So it's an important. This approach is important because in many cases we consider just the use phase, the field phase, but the impact starts since the production phase. In this case, the use of the thinner pipe will result in lower impact in terms of greenhouse gases emissions and in terms of cost. As you can see, the difference is about 40%. Assuming that the lifetime of the pipe is the same of the economical lifetime of the machine, we calculated the total impact of both pipe and the impact due to water lifting, the energy used for the pressurization of water. So the total impact using thinner pipe, the thinner hose, is lower, about 20% with respect to the traditional pipe. The same for the cost, 21% in our simulation. That it is in this case about 22,000 euros during the economical lifetime of the machine. We also considered another aspect that is relevant because the pipe can be damaged during the field use. So it is quite frequent the replacement of the pipe itself. So we assume that also during the economical lifetime of the machine, the use of two pipes. So in this case, the opportunity to use just one pipe is allowed by the use of protector. In the other case, the pipe is not protected, and the impact in terms of greenhouse gases emission and cost doubles. So under these assumptions, the pipe impact in this case is 70% lower using the thinner pipe together with protector with respect to the traditional pipe. The same for the cost, 70% less. In this case, the difference due to pipe only is about 13,000 euros. And considering also the impact of water lifting and the double and the two pipes during the economical lifetime of the machine, the difference in the total impact in terms of carbon dioxide emission and in terms of total cost increases up to 22% in the first case, that is the impact on the climate, and up to 27% with respect to the total cost. Here, according to our procedure, the difference in terms of total cost is about 30,000 euros, and in terms of impact in emission of carbon dioxide equivalent, it's about just a little less than 100,000 kilos of carbon dioxide equivalent. So let's move to the conclusions. And at the end of the preliminary test experience and simulations, the energy used for water lifting during the economical lifetime of the system is by far the greatest source of both greenhouse gases emissions and monetary costs. And at the end of the preliminary field test, results show the potential of protector in reducing both the energy use and increase the performance of hose reel machines for sprinkler irrigation. And moreover, the money that can be saved using thinner hoses thanks to protector correspond or can correspond to the purchase of the protector at the beginning of the lifetime of the system. Another important aspect is that both environment and the farm economy can benefit significantly from this smart technology, and we can also consider that research on this device is still in progress, and we expect that improved performance can be achieved. That's all, and I thank you for your attention.
Thank you, Dr. Ghinassi, for a very informative presentation and presenting the research, how the cost and carbon emission impact can be reduced by adopting the new technologies and the new research. So I now request Dr. Sergio Sacchini to give his remarks if he wished to share something with the audience.
Hello, everybody. We got this idea some years ago, and actually, time by time, going ahead with the experiences on the field and with the different possibilities. We are always more sure, let's say, that the potential is huge. Is huge, especially related to the whole market, because let's say we speak about energy saving on the field, energy saving on the material production, but we speak also about safety for the users. Let's say when hose reels are involved, especially if we speak about medium and large size systems, tons of weights are involved. So ton of weight due to the water in the machine, and ton of weight due to the machines themselves. So the safety of the operators that is allowed by using a system that need a lot less power, that's very important as well. So another important point is that all these calculations have been done in a very safe way, because for example, the lifetime of the polyethylene hose has been considered 15 years, but actually we have to consider that the hose will not worn out by using it on the field. It will, let's say, it will be a bit worse every year due to the fact that the material becomes older. But in practice, it's just a question of age of the material, not more a question, let's say, to worn it out. So we go on. We have a lot of tests already planned to go on, and next year will be, let's say, prepared also the industrialization of the product to go on with the production properly. But the last and very important thing is that we have the intention, let's say, we have an open mentality, so we have an intention to get it applied also to our competitors' machines. So let's say our target is generally the market, not only our system, because this is, let's say, the friction and the power involved is a general problem. The energy consumption and environmental is, let's say, a worldwide problem for the society. Thanks.
Thank you, Dr. Sergio. Now we open the floor for question and answer and discussion. And I request all the participants or attendees to give their questions to the chat questions, or they can raise their hand, so that we can give the speaking rights to them, and they can give their discussion, or they can raise the question to the presenters. Now we are seeing that there is one hand. One hand raised by Dr. Vijay Lavsaitwar. So we request Dr. Vijay to give his observations and views, and after that we'll give it to Dr. Seher Noraji from Iran. If they can, she can discuss or raise his views or any question on the presentation. So, Dr. Vijay, you can speak now.
Thank you, Harishji. Congratulations, Dr. Ghinassi and Sergio. This is Vijay from ICID. Fantastic presentation. Very loud, clear messages. Thank you for that. Just two simple observations. I believe you have mentioned 800,000 hectares under hose reel irrigation. Is that right?
Yeah.
Yes.
Okay. Now, out of 800,000, which is the predominant crop under hose reel?
There are multiple crops. Let's say the hose reel system is, let's say, the most versatile irrigation system. So can be used everywhere for any kind of crop. Obviously, let's say the main advantage is in open field, when you need to irrigate, let's say, different field along the same season, or eventually you have to move the system from field to field, from one season to another, because eventually the farmer, let's say, rents some different fields. So where, let's say, is less used is on orchards, let's say, on fixed, where you have fixed trees. Then, let's say, fixed systems is very common.
Okay. Thank you, Sergio. Just continuing that, when hose reel is used on the same field over a period of time, has there any effect on soil compaction?
No, I don't think so, because in general the machine, when used on the same field, moves along the same track. So, in case the problem may occur to the same lane, but not on the whole field.
Okay. Thank you, Graziano. Thank you.
But you probably introduce also another thing that is important, is the soil compactation. So when you can use the machines, the reel machines, with smaller tractors, because you need less power, then even the track that you need, it will be smaller, and imagine that the weight of the tractor will be between 1/3 and 1/4 of the tractor you normally need. So instead of, just to give you an idea, we were able to use a 60 horsepower tractor instead of a 220 horsepower tractor.
Thank you, Sergio. Thank you.
Thank you, Dr. Vijay. Now, Dr. Sahdev Singh, he's having some comment and some clarification. Dr. Sahdev Singh.
Yeah, I would like to know, in the whole of Europe, how many hectares are of this type of irrigation system?
How many what?
How many hectares of land is under this hose reel irrigation system in the Europe?
Well, we told there are about 800,000 hectares in Italy only, but in what the estimation worldwide is very difficult to know due to the fact that in many countries there are no records at all. But we surely estimate that is more than 15 million, probably 15 million hectares.
Thank you.
Okay, if anybody is having any questions, they can raise the hand from the audience. Then we'll give you the speaking rights. Otherwise, if there are no questions, then we'll close. So let me check.
Okay, there is Mehtaba. Does reduction can you keep from there?
Was me perfect.
Okay.
Okay, actually, there is one question which is from Mr. Mojava. Does reduction energy consumption affect on efficiency of irrigation system? So he's asking about is energy consumption is having any effect on efficiency of the irrigation system?
In terms of efficiency in the water use, I suppose.
We are, Mr. Morjava, we are giving you speaking right. You can speak from your microphone also and get directly the question, post question directly to Dr. Ghinassi and Dr. Sergio.
No.
Yeah, the efficiency can be improved because the total energy involved in distribution of irrigation water is lower. So the possibility to properly manage irrigation to increase efficiency thanks to lower energy to be used is yes, it's possible.
Okay, there are no questions. In that case, we'll close this webinar. First, I'll thank Dr. Ghinassi to provide the information on the research which they have done, which is leading to the energy saving and cost saving as well as reduction in the greenhouse emission. And I'll also thank Dr. Sergio to give his expert advice and then clarifications to the questions raised by the audience. I have just two small announcements. First is that recording of this webinar will be available on our website in a few days, because it takes 2 to 3 days in getting the recording and then uploading on the website. So that will be available so that anybody can look into it later on who could not attend this webinar. Second is that the 9th Micro Irrigation Conference is being organized by our Indian National Committee in January from 16 to 19 at Aurangabad, India, which is Buddhist, where there are a lot of cultural heritage structures are also there. And we invite all the audience as well as Dr. Ghinassi and Dr. Sergio to come and attend that conference in India in January. So thank you again, Dr. Ghinassi and Dr. Sergio. And
Thank you to you.
Thank you. Thank you. Bye.
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 Video बंद करो.